Okay, so here we go. We're getting ready. Sorry. Tomorrow we're going to have another quiz. There are basically, so far anyhow, two kinds of problems we're responsible for. They're the kind like you just did, where you have to graph asymptotes and all that stuff. And then there's the kind like we focused on the last couple of days, where we're just solving an equation. We're not graphing it. We're just going to come up with x equal to something. Okay, so tomorrow I'm going to give you one problem again. It's going to look like this, something like this, and you're going to have to tell me what x equals. Now, one thing to keep in mind is, on problems like this, we have some things x can't equal. They're called excluded values. So we look at this and we say, okay, I don't know what I'm going to end up with, but I know it can't be -5 and it can't be +2. So I'm not saying you have to write those down, but keep those in the back of your mind, because remember what happened on some of our examples is we get those as an answer and we have to remember to cross them off. Okay? All right, how do we start? So tomorrow you get this half sheet of paper. It's got that problem on it. How do you start? Factor. So anything that factors, we're going to want to factor. Now, nothing factors here or here. But this one, wonderfully, factors into this. Right? Now, what do we do next? Multiply everything by x plus 5 and x minus 2. So I'm going to multiply everything by x plus 5 and x minus 2. Now notice, I write that down in the numerators of every fraction. X plus 5x minus 2, x plus 5x minus 2, x plus 5x minus 2. And the reason that I did that is so that in my very next step, I could do this. Slash, slash, slash. After you have written x minus 2, x plus 5, every place, cancel it all out. Whatever will cancel. Every denominator should be gone. And leaving us then with what? What's left here? If you get rid of that stuff, you have what? 3x squared minus 6x. I'm doing my distributive, right? And then here, plus x plus 5. And over here, all you have left is 7. So we have 3x squared, okay, minus 5x. I'm going to go ahead and bring that 7 over, so it'll be minus 2 equals 0. I always like to get a 0, right? So I kind of did it all at once. I minus 7 from both sides. Is that okay with everyone? Now what are you going to do with that? You either use the quadratic formula, or if it factors, you can factor it.
3x minus 2x plus 1.
That's a good guess. Let's see if that works. Let me do a quick double check on that. Yeah, that works. When I say I'm doing a quick double check, I'm foiling. I'm going to foil and make sure that's what I get. So then I can set those equal to 0, and what do I get? X equals what? What is x equal here? Negative 1/3. Now, some of us can do that in our head, some of us can't. So if we can't, we're going to write it down. We're not going to miss it because we're too lazy to write it down. Write it down if you can't do it in your head. This one is x equals 2. Now let's double check up here. Remember we said we had some things x couldn't be?
Oh yeah, it can't be 2.
One of them was 2. Uh-oh, cross him off, and the only answer is negative 1/3. Okay? So everybody knows what's on the quiz tomorrow. One problem, just like that, do it just like that. If by chance you can't factor this, that happens sometimes. If you can't factor it, then you'll use your quadratic formula, like you always do when you can't factor something. Okay? All right, let's look at our note sheets then. Actually, I want to double check one thing. With this class, those homework practice problems that I had you do on loose leaf, did we do all 4 of those? Are we done with all 4?
Yeah.
Okay. So we're ready then to start on our note sheets, page 22. This is the last section before the word problems, and it's a big section. But we'll be okay. It's pretty easy, at least in the beginning. Notice these are inequalities. Now listen to me. Every problem that's an inequality, I want you to have a number line somewhere on your paper. For every problem that's an inequality, I need to see a number line. This problem is already mostly done for us. I'm going to put 2 dots on my number line. Does anyone want to take a guess where those 2 dots would be on my number line? -2 and +3. Does that make sense to everybody? You see where those numbers came from?
Yep.
Okay? Now, I want you to pick some other number. I don't care what other number you pick. It can't be -2 and it can't be 3. Any other number. Pick it. 4. 4 is right here. Would everybody agree with that? 4 is right here?
Mm-hmm.
So I'm going to take the number 4 and I'm going to plug it in. I get 6 times 1. I am looking for answers that are less than 0. Did I get an answer that was less than 0?
Mm-mm.
No. Less than 0 means negative. I got +6, right? So that means that this chunk of the number line doesn't work. It did not give me a negative answer. Okay? Now I'm going to share with you something that's really awesome. If that section didn't work and you tried it, you figured it out, it didn't work, it means this section will work and this section won't. They alternate. Unless you put something tricky into your problem, they will always alternate. So we picked a number, and you can choose any number you want. You picked a number here. It didn't work. That means this chunk will work and this chunk won't. So your answer is all the numbers between -2 and 3. That's my interval notation. That means all the numbers between -2 and 3. Should I color in those dots? No. I would color them in only if that had been in or equal to. Then I would color the dots in, and then my answer would look like this, right? Brackets. But because it wasn't an or equal to, I left the dots open and I used parentheses. All right, let's look at the next one. Now this one's tricky. This one is tricky because it has a squared in it. When they have a squared in them, now listen carefully. When they have a squared in them, you cannot make the assumption they're going to alternate. So when I do problem number 2, I'm going to put dots on the number line again. Where are the dots going to go? They're going to go at -2 and +3 again. But this time, because this problem is weird, it has a squared in it, so it's different, it's odd, I have to physically check every section. So I'm going to pick a number here, I'm going to pick a number here, and I'm going to pick a number here. You can only shortcut. That's what I did over here, I shortcutted. You can only shortcut if the problem doesn't have anything weird in it. No squares, no square roots, nothing funky, just plain factors. Okay? So let's pick a number. What number do you want to pick? It doesn't matter. Anything except -2 and 3. 7. So 7's out here. So I'm going to put 7 in. 7 would give me 9 times, all right, 7 would give me 4 squared 16. 9 times 16. Now I don't even care what it is. I am checking, is it negative? Is 9 times 16 negative? No. So this section doesn't work. All right, let's pick a number in here. What would be a number in here? Anything in there. 1. Let's put 1 in. 1 gives me 3 times -2 squared. 4. Does that give me a negative answer? Nope, so that one didn't work either. Remember, if you have a squared factor, weird things happen. You can't alternate, you have to check. So I gotta check this. What's the number out here?
-3.
-3. So if I put -3 in, I get -1 times -6 squared, which is 36. Does that give me a negative answer? So this section is the only section that works. So -infinity to -2. No, they only alternate if you don't have anything weird in the problem, like a square or a square root. This is your answer. Got it? Let's look at the next one. Oh my goodness gracious. Look at the next one. We've got squares all over the place. Yep.
Would there be no solutions for the problems that have 2 squares?
I don't know. We're going to find out. That's very good logic, Robbie. Very good logic. Let's take a look and see if your guess is right. Your logic's not even a guess. I think you're figuring it out. Okay, so here's the problem. Where do my dots go? Remember, if it's got an inequality, I want to see a number one.
-2, 3.
The dots are going to go at -2 and 3 again. Now we've got squares all over, so you need to check every space. So let's pick a number out here. Raven, what's a number out here? -4. It does not matter what number you pick, any number out here. So -4, now be careful, -4 would give us -2, but we're squaring it, so that's 4. -4 would give us -7, but we're squaring it, that's 49. I don't care what 4 times 49 is. Is it negative? No. So that didn't work. All right, pick a number in here, any number. 1. 1 plus 2 squared is 9. Remember, you're squaring. 1 minus 3 is -2, but we're squaring it. 4. 9 times 4, is that negative? Oh, that one didn't work either. All right, what's the number out there bigger than 3? 7. 7 plus 2 is 9, squared is 81. 7 minus 3 is 4, squared is 16. Now, I don't care what 81 times 16 is. Is it negative? Oh my gosh. What's the answer to this question? No solution. Robbie's right. None of them worked.
Will that always happen when there's two squares?
If it's less than 0, if it turned around and said greater than 0, then it would be lots of answers, right? But yes, two squares cannot multiply together to be a negative. That can't happen.
Would you want us to still show like work if a problem had
If you could tell from the beginning that it was going to be no solution, I would be okay with that if you put a little explanation. Two squares cannot be negative, or something like that. Now, look at number 4, kids. It's set up a little bit differently. What do you think you're going to do with problem number 4? You're going to factor it first. That's kind of a common theme for us. And most of our problems we factor first, don't we? So what would this factorization be?
X minus 1, X plus 4.
X minus 1, X plus 4. Are we in agreement? Okay, so then remember it's an inequality, so we need a number line. Where will the dots be on my number line? At 1 and negative 4. Make sure when you put them on there that you do it in order. Joseph, make sure you put them in the order they're supposed to be on the number line. Now, is this one weird at all? Are there any squares or anything going on in it? No, you have two plain factors. So if you want to shortcut this one, you can. You don't have to. You can work out every section, but this one is a shortcuttable problem. Okay? Because none of the factors are squared. It's not like this. Alright, so pick a number. 2. 2 is right here, right? This is where 2 is. If I put 2 in, I get 1 times 6.
Yes.
Now this time, did you notice? What's that mean? Greater than 0. Positive is 6 greater than 0.
Yep.
So this worked. Now if that one worked, this one won't, and this one will. They alternate. So your answer is everything from negative infinity to negative 4, or everything from 1 to infinity. It's the whole left end of the number line and the whole right end of the number line. So negative infinity up to negative 4, and then 1 to positive infinity. Your arrows are the infinities, right? Anybody have an issue with that one? Are you ready for number 5? What are you going to do with number 5? You're going to factor it. How does number 5 factor?
X minus 4, X minus 3.
X minus 4, X minus 3. And this one's greater than or equal to 0. So I'm going to draw my number line, because every inequality is going to have a number line drawn with it. And we're going to be looking at some different kinds of inequalities, but they're all going to have a number line, okay? Where shall I put the dots?
4 and 3.
At 4 and 3, but I'm going to put them in order, so I'll put 3 and 4. For the first time, what about those dots?
They're closed.
They're closed. These dots are closed because this problem happens to be an or equal to. Everybody catch that?
Yeah.
All right. Now, I'm going to be able to shortcut this. Nothing is squared in the factors. Remember, the factors aren't squared. So I just need to pick one number. Doesn't matter which number. What number?
5.
5. 5's out here. If I put in 5, I get 1 times 2. 1 times 2. Is that positive?
Yeah.
So this works. This won't, this will. So we're everything from negative infinity to 3, and I gotta use a bracket this time because it's a closed dot, or 4 to infinity. Got it? What would you feel like if I threw one of those on tomorrow's quiz just to give you a chance to get some more points? One like this, you think you can handle it?
Yeah.
Now, we're getting ready to do some harder ones. The one, if I put one on the quiz, it'll be like these, okay? It's not gonna be one of these harder ones. We got time, we're gonna do one more problem, we're gonna do number 6. But it is a much more challenging problem. We are gonna do it the same way, but what's the problem with it?
There's a cube.
There's a cube. Now, we still have to factor it. But we should end up, shouldn't we, with 3 parentheses now? How in the world am I going to find those 3 parentheses? Okay, factor by grouping. I love it. Unfortunately, it's not going to factor by grouping. Now, some of you tried it on your test on problems that didn't work. Look, I know I can take out an x squared. I know I can take out a negative 1. What didn't happen that has to happen? These don't match. Groupies, if those don't match, it's not happening. So this does not factor by grouping. What do I do when they don't factor by grouping? Samantha?
Take the factors.
Yep, we call them PRRs. Here we go. And we start guessing until we get something that equals 0, and then we divide it out. So I'm going to stand back and take a look at it. I'm trying to find something that. Oh, 1. 1 works. The number 1 works. I was trying to get too fancy. So I'm going to divide it out. There we go. So the number 1 worked. When I plugged in 1, I got 0, so I divided it out. Okay, is that ringing some bells? You know how to do this. What happens next? I write out this part again, and what would this part be? X squared minus x minus 6. And that will factor, won't it? So I'm going to go ahead and write my factors up here. So that would be what? X minus 3 plus 2?
Yes.
Oh, wait a minute, I'm supposed to have 3 factors.
You gotta do the opposite of the.
Oh, I got one right here, don't I? And that one is x minus 1. Remember, the number you guessed is a factor.
How did you get negative 3 and 2?
This factors.
Oh, instead of.
So when you FOIL that together, you get this. Alright, so now I'm going to the number line. I have my factors. And this time, I'll have 3 dots on my number line, right? Where will those 3 dots be on my number line?
Negative 2, 1.
Negative 2, positive 1, and positive 3. And they gotta be in order, or it won't work out right. They have to be in order.
Those are closed.
Those are closed. Good job, Chris. They're closed because of the or equal to in the problem. I don't have any squares on my factors, correct? So I can do my shortcut, but I have to try one number first so I know where I'm going.
2.
You wanna try 2? 2's fine. Now 2's in here. So this is where we're checking, right here. This is where 2 is. So 2 would give me -1 times 4 times 1. If I put in 2, I get -1, 4, and 1. Now when I multiply those together, do I get less than 0? Yes. So this section actually worked. Which means that one doesn't, this one doesn't, but this one does. They alternate. So negative infinity to -2, and that -2 is bracketed, or 1 to 3. Now, there won't be one that complicated on the quiz tomorrow, but there will be on your test. You'll have to be able to do that on your test.
So you only have to check each section on the squared?
Yep, when you have factors, so if I put a squared on there, then I have to check every section.
But not on the odd
No,
factors?
it's the factors that you look at.
Yeah.
So you don't look at the original problem.
Right.
So as long as there's no squares on those factors, you can use your shortcut.
Why do you have to check each section?
Because the squared takes away the alternating trait.
Oh, okay.
Okay? It alternates if they're not squared, otherwise it doesn't alternate. It's just a